All right, so we care about the slope of a line because, again, slopes are going to be pretty much the most important part of the first half of calculus. So if I had some random function, right? So this is f of x right here. It's this whole entire function like that, right? So there's f of x. All right, so if I took any 2 points on my graph, like this one right here, which has coordinates x, f of x, and this one over here, right? If I move h away, then I'm now at x plus whatever h was. So there's probably going to be some corresponding change in y there. All right, so this point has the coordinates x plus h, f of x plus h. All right, so what we can do is say, well, I have 2 points. I can connect them with a straight line. That straight line is what we call a secant line. Oops, made me do a different color. All right, so this line here is called a secant line. Uh, I don't know what this is also known as. It's a secant line. This is probably just a typo on my part. This is also known as a secant line. It's really important for me to emphasize the fact that it's a secant line. I feel like I should say that, like, this is known as a secant line, this is known as a secant line, something like that. All right, so what we can do is, since there's a line that hits those 2 points, we can find the slope of the secant line pretty easily. This slope is really, really, really important when we write it in functional notation. It's what we call the difference quotient. So if you haven't taken calculus before, the difference quotient is going to be a pretty big star pretty soon for us. All right, so let's first start off with our slope formula. All right, so I'm going to say m to represent the slope. All right, so we know that the slope represents the change in our vertical, the change in our range over the change in our horizontal, the change in the domain. Well, if I'm at f of x plus h, and then I want to, and I started at f of x, the best I could do here is say that this vertical change is f of x plus h minus f of x. Really common mistake students make, right? There's no way that you can distribute this f inside, right? This is not like f times x plus h, right? Something that sometimes students do. And then, well, if I look at what my horizontal change is going to be, it's x plus h minus h, well, sorry, minus x. Well, now x minus x cancels, and we have just an h in the denominator. So this formula right here is what we call the difference quotient. It's something that gets used very, 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 very often. All right, so I'll do the examples in another video. If I can get the video to stop recording.